3, 2, 1. At the exact moment the engines ignite, millions of components, thousands of sensors, and decades of engineering begin operating in perfect synchronization. A massive column of fire erupts beneath the rocket, generating enough power to shake the ground itself. For a few brief minutes, the rocket becomes the most powerful machine humanity has ever created. But modern rockets are no longer just vehicles that fly into space. They can guide themselves, land autonomously, and travel faster than the speed of sound. This is the story of how humanity built the machines that pushed the limits of physics and redefined modern technology. For thousands of years, humans looked at the sky and asked the same question: could we ever leave Earth? The earliest rockets were nothing more than primitive tubes filled with explosive powder, used mainly for warfare and fireworks. But over centuries, science and engineering transformed those simple inventions into machines capable of carrying humans beyond the atmosphere. Today, rockets do far more than launch satellites or transport astronauts into orbit. They are becoming the foundation for missions to the Moon, Mars, and beyond. What once existed only in science fiction has now become engineering reality. At its core, every rocket operates on one fundamental law of physics. For every action, there is an equal and opposite reaction. As fuel burns and hot gases are expelled downward at incredible speed, the rocket is pushed upward. In theory, the concept is simple. In practice, it is one of the most difficult engineering challenges ever attempted. Inside the engines, temperatures can rise to thousands of degrees, while enormous pressure threatens to destroy the entire system. A modern rocket is essentially a perfectly controlled explosion. The engine is the heart of the rocket, and it is one of the most complex machines ever built. Modern rockets may use solid fuel, liquid oxygen, methane, hydrogen, or highly specialized fuel mixtures. The challenge is not only generating immense thrust, but surviving the extreme conditions created by the engine itself. Fuel pumps spin at astonishing speeds, while combustion chambers become hotter than molten lava. Every component must continue functioning flawlessly, while the rocket accelerates under crushing gravitational forces. Power alone is not enough. A modern rocket must also know exactly where it is and where it is going. Inside every launch vehicle are advanced guidance systems, Modern rockets are no longer used only for military purposes or space exploration. They now support much of modern civilization behind the scenes. GPS navigation, satellite internet, weather forecasting, and global communications all depend on satellites launched by rockets. But humanity's ambitions continue to grow. The next generation of rockets is being designed to build lunar bases, mine asteroids, and eventually transport humans to Mars. For the first time in history, humanity is approaching the possibility of becoming an interplanetary species. In the future, rockets may rely on nuclear propulsion, advanced artificial intelligence, and fully autonomous navigation systems. These machines could travel millions of kilometers through deep space and carry humans to distant worlds. But perhaps the most important thing about rockets is not the technology itself. It is what they represent. Every rocket launch is proof that humanity refuses to remain limited by gravity. It reflects our curiosity, ambition, and belief that beyond every horizon lies another frontier waiting to be explored. Rockets are more than machines that travel into space. They are symbols of humanity's greatest ambition, and perhaps the true age of rockets has only just begun.